Alright guys, I'm here to make a little short video about symmetry with the X, Y, and origin. I felt like in class that when I was talking about this, a lot of people were having issues. It wasn't very clear. So bear with me. I'm going to try to give an explanation to why things operate the way they operate, and then I'll make a video about, and then I'll start going into how you actually approach the problems. So the first thing is I'm going to talk about symmetry in regards to the y-axis. Right? All you have to do to see symmetry with the y-axis is to think of something like a parabola. Right, so here is a parabola. Now what we know about a parabola is the equation of a parabola is y equals x squared. So if you take a couple points, x, y, and let's take a couple points. We take 0, we get 0. You take 1, you get 1. You take -1, you still get 1. And you get 2, you get 4. You take -2, you still get 4. Alright, so in case this isn't clear, all I'm doing is I'm substituting x as 0. 0 squared is 0. I take x, substitute it as 1. 1 squared is 1. -1 squared is 1. 2 squared is 4. -2 squared is 4. Okay, so what I want you to notice is that what this really means, this chart is really saying, is that whatever distance I go out, whether I go to the left or to the right, it is always the same distance for every height. In other words, if I go out 1, whether I go to the right or the left, it will always have a height of 1. And so what we do in mathematics is we're really trying to find a way to say it doesn't matter what numbers you substitute in, this is the general behavior. This is what happens. And the way we do this is through letters. Okay? And so what we say is, drawing the same exact picture, what it really is whether I go x to the left or to the right, they share the same y value. Okay? So what that means is that it has symmetry with the y-axis. So what that means, what does that mean? That means if you took this side here and you folded it along the y-axis, it would match up with this side here, because the distance from here to here and from here to here is the same. All right. So now that I have this piece of information, we can write this in a different form. So the first thing is that if symmetry with the y-axis, it's important to note that this is what's known as an even function. Okay. So this isn't 100% clear and 100% accurate. This exponent being even helps me to know that it's an even function. In fact, if all I have are even exponents, the function tends to be even. All right. So even functions have symmetry with the y-axis. All right. Now, if you look in the same argument, if I have a function that is symmetrical with the x-axis, it's the same argument but just twist it. It means that the distance of y up and down, whether I go up or down, it shares the same x value. Okay? And so what would tend to happen is you'd actually end up with y squared as opposed to x squared. So y squared plus x equals 10, for example, would be an equation that has symmetry with the y-axis. All right. The last case that we know about, which I don't think is nearly as clear, is symmetry with the origin. Okay. What tends to be the case here is that if you have symmetry with the origin, that means that you switch your x and your y points. Okay. This is, when it was with the origin, it's also known as an odd function. Okay. Now we do have some fancy math notation for even and odd functions. Note that symmetrical with the x-axis, it actually is not a function because it fails the vertical line test. All right. If it's an even function, it follows this form here. Okay. And this notation is a little intimidating, but all it's saying is that whether x is negative or positive, they share the same y value. Note, y is the same thing as f of x. Okay? And down here, it's with the origin, when we have f of negative x, it's the same thing as negative f of x. Okay? What this means is that when I switch my x values from negative to positive, from positive to negative, what happens is I also switch my y values from positive to negative, negative to positive. In other words, it's the opposite of what it once was. Okay? So this is kind of a general grasp of what we're talking about here when we talk about even and odd, in terms of why it is what it is. And you probably need to watch this video a couple times to really try to grasp what I'm trying to argue. Or perhaps after doing some problems, watch this video again, and maybe it makes a little more sense as to what I'm trying to show here. I know this is a difficult concept because I'm playing a little bit with the abstract as opposed to concrete numbers. All right, well, enough about that. Let's look at some concrete examples. So, if you look on page 5 of your notes, number 2, they ask you to test for symmetry, and the function is y equals x squared minus 5. Okay? And so, what we're going to do here is we have to decide whether it's whether it's symmetrical with the x-axis, the y-axis, or the origin. Okay? Now, you'll hear me sometimes say, when we go talk about symmetry with the y-axis, I'll sometimes use the synonym that it's even, because, right, if it is symmetrical with the y-axis, it does tend to be even. So I may tend to use that verbiage instead. So just note that they're the same thing. Now, what did I say earlier? I said if it's even, you can basically automatically deduce that it's going to be symmetrical with the y-axis. So when I see this, I kind of already know that it's symmetrical with the y-axis. In fact, if you drew a picture of it, all that happens is that negative 5 means the function does what? It means the function drops to negative 5. Okay? It's a vertical translation down negative 5. So that clearly is symmetrical with the y-axis. But the way we approach this in terms of the notes is that what we can say is if x is negative, if this becomes the original equation, then what does that mean? That means it has the same y value. Okay? Think about this for a sec. Whether it's positive or negative, if I make this negative and it turns out that this equation, this right-hand side matches this side here, it means that they have the same y value. So going back to our original definition, this notation is difficult, slightly difficult to understand, but it's at the end of the day, it actually is very useful. Saying if x is negative here, then it has the positive, says whether it's negative or positive, they share the same y value. Okay? So looking now here, is that true? Well, what happens when you square a negative? Well, a negative times a negative is a positive, and x times x is x squared. In other words, what this means, and I would never ask that you write this completely out like this, you wouldn't have to, but just to show you the clarity, this part here becomes this, okay, just for clarity's sake. So it gives me x squared minus 5. Negative times negative is a positive, x times x is x squared. All right? And so this function does have symmetry with the y-axis. All right. Hopefully that's a little clear. In the next video, I'm gonna go through and I'm gonna do example 2b. So I'm gonna break this up and partition this into a bunch of several little videos, and that way you can focus on what you need help with. Hope this helped out. Let me know. Post some comments. Ask me in class. Do what you need.